In this segment, we will review basic types of problems involving percents. We will also take a look at some applications from chemistry. Now, we can categorize percent problems really in two groups. First, the question may ask you to find X% of a given quantity. And second, you may be asked to determine what percentage of the whole a given quantity is. So in one of them, you're finding a given percent of a given quantity. In the other one, you're actually determining the percentage amount itself. So one, the answer would be like 5%, that's the unknown. The other one will be an actual quantity like 5 grams or $10 or something like that. So one is asking you for the percent, one is asking you for the actual quantity. So we'll begin with the first type of problem, and then in the second segment, we'll go over the questions of the second type. So the main goal here then is to understand how to do questions of the form finding X% of a given quantity. Here's a very basic example. Find 10% of $200. So 10% can also be written as 10 divided by 100. As a matter of fact, percent means per 100. And it literally, the word cent in French pronounced as son is really, it represents the number 100. So percent means per 100. So when you have 10%, we can write it as 10 over 100. So to take 10% of 200, you do 10 over 100 times 200. And you can simplify this in a number of ways. And one of them is this 100 goes into 200 two times. And 2 times 10 is 20. So the answer is $20. And some of you may have done this in your head. You know, numbers are simple in that situation. You can really use intuition. So 10% of 200. So that's really like 1/10 of 200. And you can move the decimal 1 unit to the left. And that gives you the correct answer of $20. Now, it's important to realize that 10% can also be written as 10 over 100. And as a decimal, that same value, if you put this in a calculator or do it in your head, anything divided by 100, you move the decimal 2 units to the left. As a decimal, it will give you 0.10. So 10% can be written as a fraction like this and as a decimal like that. In this situation, 10% of 200 was equal to $20. Okay, what about calculating the tip? Like there's a $35 bill and we're asked to find the 20% tip for that bill. So calculate 20% of $35. Basically, that's what the question is asking us. So once, just like the problem above, 20% of $35. So you could say 20% is the same as 20 over 100 of $35. So we'll multiply it by $35. And again, you can simplify this a number of ways. Right now, let me write this as a decimal. 20 over 100 is 0.20 times 35. Again, you can do this on the calculator. You can do this by hand, but regardless, you're going to get the answer is $7. And how could we have done this, in our heads? Say we're in a restaurant and there's you want to do this quickly enough and not having to pull out a calculator and so forth. So one of the easiest ways to do this is first figure out what 10% of $35 is. So 10% of $35, so there basically you're multiplying by 0.10, that is move the decimal 1 unit to the left. So 10% of $35 is $3.5, $3.5. So 20% will be twice as much, which is $7. So that's how I would do it in a restaurant. Find 10% and then in your head multiply it by 2 to get 20%. Okay, here's another practical question. You know, we've all been to sales and they put the amount, they put the percentage sale, but sometimes they don't necessarily put down the final value for that item. And we want to evaluate, like in this situation, if the price of a shirt is $40 and it's on a 30% sale, what will be the final price? So for this question, we could begin by finding, first of all, 30% of $40. So again, you can do 0.30 times $40, which will be $12. And that's the amount of the sale, how much will be reduced from the original price. So since we're asked to find the final price will be $40, the original amount, minus $12, the amount of the sale, and that gives us the final price of $28. Again, could you have done this in your head with a slightly easier approach? Here's another possible way to do it, and possibly we can do it without any calculators and pretty quickly. So 30% on sale. What that means is 30% of the price will be deducted. That means what's going to be left over is 70% of the price of that item. So that's what you're going to have to pay, 70% or 0.70 times the original amount, which is $40. And you can do this in your head really quickly by just doing 7 times 4 is 28. And in terms of deciding, typically if it's a $40 item, you will have a pretty good idea about what it will be. So you don't have to worry too much about the decimals. So if you have something, let's say, that is on a 40% sale, that means the remaining amount will be 60%. So what I do is I multiply the given amount by 6 and figure out intuitively where the decimal should be. So like for $40, 4 times 7 is 28. So the final amount will be $28. So that's another approach. And I find that to be very helpful when you're trying to do quick calculations on the fly. Okay, here's another example. When you're at rest, your heart pumps at 5.0 liters of blood per minute. Your brain gets about 15% by volume of your blood. What volume of blood in liters is pumped through your brain, once again, in 1 minute? That should be a part of the question. So basically, all this question boils down to saying, what is 15% of 5 liters? Because 15%, your brain gets 15% of the blood that your heart pumps during a given time interval. And we're talking about the same time interval, so we don't have to worry about that part right now. So all we need to define is 15% of 5 liters. So simply we're going to do just like the last few examples, just take 0.15 times 5.0 liters, and the answer will be in liters as well. So just go ahead and multiply 0.15 times 5.0 and you will get 0.75 liters. Everything was in terms of per minute. We didn't touch that part of the problem, so this will also be the brain gets 0.75 liters per minute. And notice that when there is a measured quantity, as you have learned or you're about to learn in your science classes, you also need to consider the number of significant figures. In this situation, this is 5.0. It has 2 significant figures, and therefore we're going to leave our final answer in 2 significant figures as well. Okay, an example from chemistry. And before we look at the example, here is something you might see in your chemistry classes, and maybe you've already seen it. X% by mass means X grams of solute in 100 grams of solution. And this could also be X kilograms of solute in 100 kilograms of solution, etc. It could be any given unit of mass, but typically grams are used very commonly, so that's what we're using here. And there are different interpretations for percent by mass, so make sure you read your textbook carefully when you get to that section. At the moment, we're going to assume this interpretation. The question is asking us how many grams of NaCl or sodium chloride are there in 150 grams of a 6% by mass sodium chloride solution. So how many grams of the actual substance will you find in 150 grams of a 6% by mass solution? So 6% by mass, based on this interpretation, means 6 grams of sodium chloride per 100 grams of solution. Okay. And we happen to have 150 grams of solution. So I'm going to multiply this by 150 grams of solution. And notice that the grams of solution, those units cancel, and we're going to be left with grams of sodium chloride when we're done with this. And what we have here is 6.0 times 150 on the top, and on the bottom 100. And let's go ahead and evaluate this. And an alternative approach would have been just to take 0.060 times 150, which also will give you the same answer. But in your chemistry classes, you might see this unit conversion method, and therefore I wanted to solve this problem with that approach. So when you do that, when you multiply 6.0 times 150 divided by 100, and considering the number of significant digits, significant figures, again, this is your measured quantity, 150. It has 2 significant figures, and the percentage is given in 2 decimals, in 2 significant figures rather. So the final result should also have 2 significant figures. It will be 9.0 grams of sodium chloride. Again, with the other approach, the approach that we've been using so far, if you have basically a 6% solution by mass, that means 6% of that entire quantity will be the active ingredient, sodium chloride. So you would just take 6% of 150, which is 0.06 times 1, and because there's extra 0 there, significant figure. So 0.060 times 150. And that turns out to be exactly 9. And because we have 2 significant figures, we leave the answer as 9.0. So in one situation, we use the fractional approach, which looks like a conversion factor. And in the other approach, we use the decimal approach, but either way we do it, we get the same final answer. And here's our next example. A 400 milliliter solution composed of oil and vinegar contains 25% vinegar by volume. How many milliliters of vinegar is contained in this solution? So 400 milliliters for the entire solution. And basically we're asked to find 25% of that total amount because that's how much vinegar there will be. So all we have to do is take 25% of 400. So we can write it as a decimal. 25% is the same as 0.25 times 400, and that will give us 100 milliliters if you multiply these two together. You can also notice, of course, 25% is the same thing as 1/4. So if you take 1/4 of 400, that will also give you 100 milliliters. And the other approach, again, is to write 25% as a fraction. Then you can write it as 25 over 100. So that means there's 25 milliliters of vinegar in every 100 milliliters of solution, or per 100 milliliters of solution, and multiplied by the given amount, which is 400 milliliters of solution. And these are going to cancel the units, and you're left with milliliters vinegar as the final answer. So 25 times 400 over 100. And similarly, 100 goes into 400 four times. 4 times 25 is 100. Of course, if you prefer, you can just put the whole thing into the calculator. But sometimes for basic things, it's good to know how to do them by hand, or just use some intuition so you can check your final answer and you can check the reasonableness of the final answer. And here's our last example for this segment. So we have the mass of the ocean, 1.8 times 10 to the 21 kilograms. And suppose that this body of water contains 0.014% by mass hydrogen carbonate ions, HCO3. How many kilograms of hydrogen carbonate ions then are in this body of water in the ocean? So it's a very similar question to everything we've done. The numbers are just a little bit messier. The first thing is, okay, we have 0.014%. How would you write that as a decimal? 0.014%. So if you had like 25%, the way you write it as a decimal is you say this is the same as 0.25, right? And then you multiply your entire quantity by 0.25 to take 25% of something. So basically 25% of 0.25, you're dividing your number by 100 there, right? Moving the decimal to the left by 2 units. So if you have 0.014%, move your decimal 2 units to the left. So then you're going to have 0.00 0.00014. So that's how you convert that percentage to a decimal, and then you can take that value and multiply it by the given quantity to find 0.014% of the given quantity, and that will give you the actual amount of the hydrogen carbonate ions. So if you multiply those two, and the way I did it is first I multiplied just 0.00014 times 1.8. I just multiplied those two together on the calculator, and I got 2.52 times 10 to the negative 4. But then, again, if you've studied scientific notation already, you can also simplify this further. Here you add the powers, that gives you 17th power. And then recognizing that we only need to use 2 significant figures based on a given measurements. Here I ran to 2 significant figures, 2.5 times 10 to the 17. And if you're doing it with the division process instead of the decimal process, just take your given percentage, which was 0.014%, and remember, percent means per 100, so you write that as the given value over 100, and then take that quantity, multiply by the given value in kilograms, and you will come up with the same final results. So make sure you watch part 2 to understand how to solve the second type of percentage problems, the ones where you're going to find the actual percent that will be the unknown for those questions.